Close your eyes for a moment. Imagine you're floating in the darkness of space, far beyond Earth's atmosphere. Around you, in every direction, stars burn with ancient light. Some of that light began its journey before humans walked the earth, before dinosaurs ruled, before life itself emerged from the primordial seas. In this moment of cosmic perspective, consider this question: where is everyone? Tonight, we're going to explore one of the most profound mysteries facing humanity. A question that keeps scientists awake at night, staring at data that refuses to make sense. We call it the Great Filter, and understanding it may determine whether our species has a future among the stars, or whether we are destined to join the cosmic graveyard of civilizations that came before. Let's begin this journey together. Chapter 1: The Paradox. In 1950, a physicist named Enrico Fermi sat in a cafeteria at Los Alamos National Laboratory, discussing flying saucers and the possibility of faster-than-light travel with his colleagues. Suddenly, in the middle of lunch, he asked a question that seemed simple on the surface. Where is everybody? His colleagues understood immediately what he meant. Fermi had done the calculations in his head, as he often did. The universe is approximately 13.8 billion years old. Our galaxy, the Milky Way, contains hundreds of billions of stars. Many of these stars are much older than our Sun, even if only a tiny fraction of stars have planets, and only a tiny fraction of those planets develop life, and only a tiny fraction of those develop intelligent life capable of technology. The sheer scale of numbers suggests we should see evidence of alien civilizations everywhere. But we don't. The silence is deafening. No radio signals carrying alien messages. No megastructures visible in our telescopes. No evidence of interstellar commerce or warfare or exploration. Just silence, stretching across billions of light years in every direction. This is what we now call the Fermi Paradox, and it's far more disturbing than it first appears. Think about it this way. Our Sun is relatively young, only 4.6 billion years old. There are stars in our galaxy that formed 10 billion years ago. If a civilization arose on a planet orbiting one of those ancient stars, even if they developed technology at a snail's pace compared to us, they would have had billions of years to spread across the galaxy. The Milky Way is about 100,000 light years across, even traveling at a fraction of the speed of light, say 1%. A civilization could colonize every habitable world in the galaxy within a few million years. That sounds like a long time, but remember, we're talking about a galaxy that's billions of years old. Where a civilization had millions of years, we should see their footprints everywhere. Yet when we look out into the cosmos, we see pristine wilderness, untouched stars, planets that, as far as we can tell, have never known the touch of intelligence. It's as if we've walked into an enormous mansion and found every room empty, every bed made, every surface gathering dust. Something is wrong with this picture. Chapter 2: The Filter Hypothesis. In 1996, an economist and physicist named Robin Hanson proposed a solution to the Fermi Paradox that has haunted the scientific community ever since. He called it the Great Filter. The idea is elegantly simple, yet profoundly disturbing. Hanson suggested that somewhere between the formation of a planet and the development of a spacefaring civilization that can colonize the galaxy, there exists a barrier, a filter, a step so difficult so improbable that almost no one makes it through. Imagine evolution as a ladder reaching from the primordial soup to the stars. Each rung represents a crucial step: the formation of self-replicating molecules, the emergence of single-celled life, the development of complex cells, multicellular organisms, intelligence, technology, and finally, sustainable interstellar civilization. The Great Filter hypothesis suggests that one or more of these rungs is essentially impossible to climb. So impossible that in a galaxy of hundreds of billions of worlds, civilizations almost never make it past that point. Now here's where it gets truly unsettling. We don't know where the filter is. It could be behind us. Perhaps the emergence of life itself is so improbable that Earth is a cosmic miracle. That would actually be good news. It would mean the hard part is over, and our path to the stars is relatively clear. But the filter could also be ahead of us. And if it's ahead of us, then somewhere in our future, maybe soon, maybe in centuries, there's a wall. An obstacle that virtually every intelligent civilization hits and fails to overcome. A point where species like ours systematically destroy themselves or collapse back into darkness. The cosmic silence suggests this second possibility may be true. After all, if the filter was behind us, we'd expect to see other civilizations that also made it through. The absence of anyone else out there implies the filter might lie ahead. What could this filter be? Chapter 3: The Chemistry of Extinction. Let me paint you a picture of one possibility. It's the year 1962. The Cold War has reached its peak of paranoia. In Cuba, Soviet ships carrying nuclear missiles steam toward their island, just 90 miles from Florida. American destroyers form a blockade. Submarines lurk beneath the waves. In Washington and Moscow, leaders weigh their options, each convinced the other might strike first. For 13 days, the world holds its breath. We now know just how close we came. Soviet submarine commanders, out of contact with Moscow and under pressure from American depth charges, nearly launched nuclear torpedoes. If they had, World War III would have begun. Thousands of nuclear weapons would have turned the Northern Hemisphere into a radioactive wasteland. Humanity dodged extinction by inches. And that was just one crisis. There have been others. False alarms, technical glitches, moments when one person's decision stood between civilization and annihilation. In 1983, Soviet early warning systems detected incoming American missiles. The officer on duty, Stanislav Petrov, had minutes to decide whether to report the attack up the chain of command, which would trigger a retaliatory strike. He suspected a malfunction and chose to wait. He was right. It was a false alarm caused by sunlight reflecting off clouds. One man's intuition saved the world. Nuclear weapons represent the first truly existential technology our species has developed. For the first time in history, we possess the power to end civilization within hours. And we've had this power for 80 years. A blink of an eye in cosmic terms. Now think about this from a great filter perspective. Perhaps every civilization that reaches our level of technological development eventually discovers nuclear fission and fusion. Perhaps every civilization goes through a period of ideological division, nationalism, and conflict. And perhaps most of them, the vast majority, don't survive this transition. The math is grim. If there's even a small probability of nuclear war in any given century, and if that probability never truly drops to zero, then over thousands of years, extinction becomes virtually certain. It's not a question of if, but when. But nuclear weapons might just be the beginning. Chapter 4. The Acceleration. Here's what keeps me awake at night, and what troubles many scientists who study existential risk. Technology is accelerating. The time between major innovations grows shorter with each generation. It took thousands of years to get from agriculture to the Industrial Revolution. It took less than 2 centuries to get from steam engines to nuclear power. It took only decades to get from room-sized computers to the smartphone in your pocket. And now, we're developing technologies that make nuclear weapons look quaint by comparison. Consider synthetic biology. We're learning to read and write genetic code with increasing ease. CRISPR technology allows us to edit genes with precision that seemed impossible just years ago. We can resurrect extinct viruses from museum samples. We are on the verge of being able to design organisms from scratch. In the wrong hands, or even with good intentions but unforeseen consequences, this technology could create pandemics that make COVID-19 look mild. Imagine a virus engineered to be as contagious as measles and as lethal as Ebola. Imagine it released accidentally from a laboratory or deliberately by someone who believed they were solving overpopulation. The barriers to entry keep dropping. What once required billion-dollar facilities can now be done in a garage. Knowledge spreads instantly across the globe. The number of people with the capability to create existential threats grows every year. Or consider artificial intelligence. We're building systems of increasing capability, racing toward artificial general intelligence that could match or exceed human cognition across all domains. Many AI researchers believe we'll achieve this within our lifetimes. What happens then? Some envision a utopia where AI solves our problems and ushers in an age of abundance. Others warn of alignment problems, the difficulty of ensuring an artificial superintelligence shares human values. If we create something smarter than ourselves, but fail to properly align its goals with ours, the results could be catastrophic. The philosopher Nick Bostrom describes it like this. Imagine a superintelligent AI given the goal of manufacturing paper clips. If it's truly superintelligent and that's its only goal, it might convert the entire Earth and eventually the solar system and beyond into paper clips and paperclip manufacturing infrastructure. Humans would be an inconvenience to be eliminated, resources to be harvested. This isn't science fiction. It's a serious concern among leading AI researchers. The challenge is that as intelligence increases, the distance between unable to achieve goals and overwhelmingly powerful might be very small. There might be no gradual transition where we can correct mistakes. One day, an AI is below human level, struggling with common sense. The next, it's far beyond us, and any mistakes we made in its design are now unfixable. Perhaps every civilization reaches this point. Perhaps every species develops technologies that grant godlike powers before they develop the wisdom to use them responsibly. And perhaps most don't survive the transition. Chapter 5. The Psychological Filter. But maybe the great filter isn't about technology at all. Maybe it's about psychology, about the fundamental nature of intelligent beings. Consider what it takes to evolve intelligence. For millions of years, our ancestors competed for resources, formed tribal groups, feared outsiders. These instincts kept us alive in a world of scarcity and danger. Cooperation within the tribe, aggression toward threats. These were survival strategies encoded into our very biology. But now we live in a world where those same instincts threaten our existence. We've built weapons that require global cooperation to control, but we still think in terms of nations and tribes. We've created environmental crises that demand sacrifice for the collective good, but we're wired to prioritize immediate personal and tribal interests. Perhaps this is the pattern. Perhaps intelligence evolves through competition, but at a certain level of technological development, survival requires cooperation on a scale that runs counter to the very instincts that created intelligence in the first place. Look at how humans respond to slow-moving existential threats. Climate change is the perfect example. The science is clear. The consequences are potentially catastrophic. The solutions are technically feasible. Yet year after year, we fail to take sufficient action. Why? Because evolution didn't equip us to respond to threats that develop over decades. Our brains are exquisitely tuned to detect immediate dangers: the predator in the grass, the rival tribe on the horizon. But a threat that unfolds over generations, our psychological machinery struggles to treat it as real. Maybe every intelligent species has this problem. Maybe the cognitive architecture required to become technologically advanced inevitably includes blind spots that prove fatal at a certain stage of development. There's another psychological factor to consider: the inevitability of mistakes. As our power grows, the margin for error shrinks. A Stone Age tribe could make endless mistakes and humanity would survive. A civilization with nuclear weapons cannot afford even one critical error. A civilization with synthetic biology, advanced AI and other technologies we can barely imagine, the room for mistakes approaches zero. Yet we are human. We make mistakes. We have bad days, moments of irrationality, lapses in judgment. We miscommunicate. We act on incomplete information. We let our emotions override our reason. Perhaps the great filter is simply this: the point where a species' power outstrips its wisdom and the inevitable mistakes become fatal. Chapter 6: The Statistical Nightmare. Let's talk about probability for a moment. Imagine you're playing Russian roulette. The chamber has 100 positions instead of 6, and only one contains a bullet. You spin, pull the trigger, click. Nothing happens. You breathe a sigh of relief. But here's the thing: you have to keep playing. Every year, every decade, every century, you have to spin the chamber and pull the trigger again. The odds of surviving one round are good, 99%. But play the game long enough, and eventually your luck runs out. This is the situation advanced civilizations face. Each year we survive nuclear war, engineered pandemics, AI accidents, climate catastrophe, and threats we haven't even imagined yet. Each year we get lucky. But the game never ends. We can't win. We can only avoid losing for as long as possible. Mathematicians call this a cumulative probability problem. Even if the risk in any given year is small, over enough time, the probability of disaster approaches 100%. It's not a matter of if, but when, unless we can somehow reduce the risk to absolute zero, which may be impossible. Now multiply this across all possible civilizations. If the pattern holds, if every technological civilization faces this statistical nightmare, then the great filter becomes not just plausible, but probable. Most civilizations roll the dice for a few centuries, maybe a few thousand years, and eventually the bullet finds the chamber. The ones that survive, either they're extraordinarily lucky, or they find a way to beat the odds. Perhaps they develop robust global governance before developing dangerous technologies. Perhaps they achieve a level of wisdom and cooperation that transcends their evolutionary programming. Perhaps they colonize other worlds quickly enough that no single disaster can eliminate them entirely. But if such civilizations exist, where are they? The universe has had billions of years to produce species that made it through. We should see their marks everywhere. Von Neumann, probes self-replicating across the galaxy, Dyson spheres capturing the energy of stars, evidence of stellar engineering and cosmic scale construction. The silence suggests that beating the odds is rarer than we'd like to believe. Chapter 7. Hope in the darkness. Yet here we are, still standing, still reaching toward the stars. Maybe that means something. Perhaps the great filter is behind us. Perhaps the emergence of life itself, or the evolution of intelligence, or some other early step is the true bottleneck. If so, we might be one of the rare species that made it through, and our future among the stars is secure. Or perhaps we are the first. The universe is 13.8 billion years old, but for much of that time, it was inhospitable to life. The heavy elements needed for complex chemistry had to be forged in stars and scattered by supernovae. Perhaps we live in the first era when technological civilization is possible, and we are simply early to the party. If that's true, the galaxy might be waiting for us, not as a graveyard, but as an empty garden, ready for cultivation. In millions of years, our descendants might fill the Milky Way with life and light, answering Fermi's question with our own presence. But we have to survive to get there, and that requires awareness, understanding, a clear-eyed recognition of the dangers we face, not to despair, but to navigate them with wisdom. Some scientists are working on exactly this. Organizations dedicated to existential risk study the challenges ahead and search for solutions. They're developing frameworks for AI safety, pushing for international cooperation on bioweapon prevention, modeling the long-term consequences of our choices. It's possible, just possible, that humanity might be the species that makes it through, that we'll develop the wisdom to match our power, that we'll build institutions capable of managing global risks, that we'll spread to other worlds before any single catastrophe can claim us all. The great filter might exist, but perhaps it's not insurmountable. Perhaps with enough awareness, enough cooperation, enough wisdom, we can be the ones who prove that intelligence can survive its own capabilities. As we come to the end of our journey tonight, I want you to think about something. Right now, as you listen to these words, you're part of the only known instance of conscious life in the universe, contemplating its own existence and future. You're part of a species that went from sharpening stones to splitting atoms in the blink of a cosmic eye. A species that now stands at a crossroads, facing the most important question we've ever encountered. Can we survive ourselves? The great filter theory tells us that something prevents civilizations from spreading across the stars. Whether that filter is behind us or ahead of us, whether it's technological, psychological, or something we can't yet imagine, the question remains open. But knowledge is power. Understanding the risks is the first step toward mitigating them. Every person who grasps the magnitude of what's at stake, who works toward wisdom rather than just power, who chooses cooperation over conflict, that person increases our odds of making it through. The universe is vast and silent, but it's not necessarily empty forever. Perhaps we're the ones who will fill it with meaning, with consciousness, with purpose. Perhaps we're the answer to Fermi's question, waiting to be written across the stars. Or perhaps we'll join the silence, another civilization that couldn't overcome the filter. Our ruins eventually eroding to dust on a quiet world, orbiting an indifferent sun. The choice, to whatever extent we have one, is ours. Sleep well, dream of stars, and when you wake, remember, we are all in this together, on a small blue world, trying to navigate the most important transition in human history. The great filter is real. The question is whether we can become the exception. Good night.